This is SpaceTime, Series 29, Episode 74, or broadcast on the 22nd of June 2026. Coming up on SpaceTime, why Venus spins backwards. Could dark matter explain what's happening at the centre of our galaxy? And trying to solve a meteor cold case. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that the strange retrograde spin of the planet Venus could be the result of a massive impact event. Unlike most other planets in our solar system, Venus rotates in reverse, with the Sun rising in the west and setting in the east. And the planet's rotation is so slow that a Venusian day takes 243 Earth days. That's longer than its year, which is 225 Earth days. The planet's bizarre and extraordinarily slow retrograde rotation has long puzzled astronomers. The new findings, presented at the European Geosciences Union General Assembly in Vienna, suggest that the planet may have been hit by a high-angle, moon-sized, high-velocity impactor, probably within the first 50 million years of its formation. The study's lead author, Cedric Gilman from ETH Zurich, says computer simulations show that just such a collision could have significantly modified the rotation of the planet's initial spin. Gilman and colleagues found that an initial impactor with about a tenth the mass of Venus hitting the planet at just the right angle could drastically change its rotation. Venus is often called Earth's sister planet because it's almost the same size as the Earth and was formed in the same part of the solar system, out of the same materials and under similar conditions. But Venus evolved very differently compared to the habitable world we call home. Venus has an average surface temperature of 467 degrees Celsius. Now that's hot enough to melt lead. And its atmospheric surface pressure is a crushing 92 times that of Earth. Its dense carbon dioxide atmosphere is blanketed under a 20-kilometre thick global cloud cover. On Venus, it's always overcast. But it doesn't rain water on Venus. Instead, the rain is sulfuric acid, with metallic snow caps covering the planet's tallest mountains. Now, according to Gilman and colleagues, depending on the impact parameters, a collision could have either slowed down a rapidly rotating early Venus to a slow spinning planet, or alternatively, with a large enough tangential energetic impact, it could have caused a faster retrograde rotation. The computer models show that any major impact would have produced vast surface magma oceans, with melt layers ranging from 100 kilometres thick right down to a fully molten mantle, depending on impact properties. The simulation most likely to cause the planet's current retrograde rotation likely melted some 99% of Venus's mantle. Only a slightly larger impact might have been enough to destroy the planet completely, and that means the inner solar system would have been a very different place, possibly one inhospitable for life. Now, this study doesn't explain Venus's lack of plate tectonics. That could be due to the crust soaking heat, keeping it all soft and malleable, resulting in volcanism being the primary heat dissipation source. Now, these are only computer simulations as to what may have happened, but it does provide an explanation for what we're seeing in this strange, twisted sister of a planet we're neighbours with. This is SpaceTime. Still to come, could dark matter explain what's happening at the centre of our galaxy? And trying to solve a meteor cold case. All that and more still to come on SpaceTime. A new study has failed to rule out dark matter as the potential source of the so-called galactic center excess at the heart of our Milky Way galaxy. The galactic center excess is a roughly spherical glow of gamma rays extending over thousands of light years around the center of the Milky Way, and its origins are among the most hotly debated issues in astrophysics. Several explanations have been put forward to try and explain this unusual signal, and some theoretical predictions are consistent with self-annihilating dark matter, a mysterious invisible substance that makes up 80% of all the matter in the universe. Of course, the problem is scientists have no idea what dark matter really is. They know it exists because they can see its gravitational interaction with normal matter, preventing galaxies from spinning apart as they rotate and magnifying background objects through gravitational lensing. But really, that's about it. Other than dark matter, another possibility is a large population of rapidly rotating neutron stars known as millisecond pulsars. But again, that's just a hypothesis. For now, the origin of the signal at the centre of our galaxy remains unresolved. And that's where this new study comes in. The research, reported in the journal Physical Review Letters, used a new machine learning method incorporating for the first time the energy of photons to try and resolve the mystery. And these new results suggest that an explanation in terms of dark matter can't be ruled out. The study's lead author, Florian List from the University of Vienna, says interpreting the signals is especially difficult because the galactic centre is an exceptionally bright and crowded region of the gamma-ray sky. The pulsar hypothesis has been supported by previous statistical studies. The problem is earlier analyses haven't included a crucial piece of information, the energy of each individually detected photon. In this new study, List and colleagues developed a machine learning method trained on more than 1 million simulated gamma-ray observations in order to evaluate spatial and spectral information simultaneously for the first time. And including this new photon energy information changes the picture substantially. Whereas earlier analyses pointed to comparatively bright, unresolved light sources, the new results showed that these point sources would have to be extremely faint, in fact so faint they'd be almost indistinguishable from the emissions expected from annihilating dark matter. And for the pulsar hypothesis, it would imply there must be at least 35,000 such sources at the centre of the galaxy. And that's significantly more than the few hundred to a few thousand sources assumed in previous studies. List admits the new work doesn't show that dark matter is responsible for the gamma-ray signal, but it does suggest that it's still far too early to rule it out. This is SpaceTime. Still to come, trying to solve a meteor cold case. And later in the science report, a new study has confirmed the risk of suicide among males can linger for years following the breakup of a relationship. All that and more still to come on SpaceTime. Last month, astronomers detected a small near-Earth meteoroid on a collision course with our planet. The object was estimated to only be about half a metre wide, and it was expected to impact somewhere between Papua New Guinea and northern Western Australia. The head of the Desert Fireball Network, Hadrian Devipois, from the Curtin University School of Earth and Planetary Sciences and the Curtin Institute of Radio Astronomy, says the object was travelling at some 13 kilometres per second and would have been visible up to 900 kilometres away. However, that's where the story ended. Despite a heads up to space researchers and citizen scientists, there were no sightings or impact reports. At least that was until a few days ago, when a report suddenly surfaced on social media. Apparently, a man fishing with his father along the Northern Territory's Adelaide River estuary posted a possible sighting of the meteor as it streaked across the late-night tropical skies. Devipois says, while we now have telescopes that can detect asteroids before they hit the Earth, once they get really close to the planet and hit the atmosphere, we lose track of them. And he says that's where citizen scientist reports could really help. So he's calling for people across the territory's top end who may have seen a bright fireball, an unusually bright flash on the horizon, or heard a sonic boom from the impact to get in touch with the network.
So basically, as we get better telescopes for discovering like asteroids, like we're discovering small and small objects. And as we're discovering small and small objects, we're starting to discover the ones that like regularly like hit the Earth. So people be used to seeing like meteors at night time. So those are like really, really small. It's only kind of like millimeter to centimeter stuff. But those telescopes starting to discover like objects maybe half a meter across. And these typically impact the Earth on the order of like maybe like 50 to 100 times a year. So it's pretty exciting. We're at a point where like astronomy is kind of like meeting like meteor science. We're starting to see the same objects. So yeah, pretty exciting. So far, we've only seen 12 objects before they impacted. So 12 small asteroids. And that was the 12 takeoff one, the one that was discovered on May 15th. And for all the previous one, the 11 before, we had some confirmation of impact. The telescope saw it, we got an alert, and then somebody on the ground, either optically or acoustically, basically got an indication that the impact actually happened. So the cool thing, this one, we got no confirmation. The telescope dial tells us, it should have impacted somewhere north of Australia, but we've got no proof, basically.
And then all of a sudden, this guy from Adelaide River in the Northern Territory, he made a post on Facebook.
Yeah, so it was almost 3 weeks after the fact. So he was actually on holiday fishing in Northern Territory, and apparently on his boat and saw a big fireball. So we were on the lookout for reports of people seeing this thing, and we didn't know. We weren't sure exactly where it was going to be, so we didn't usually send an alert to tell people to look out, because the area would have been pretty massive. It would have impacted anywhere between Papua New Guinea to North WA, so it would be hard to tell people, hey, look out, you might see something interesting, because the probability of people seeing stuff at any one point was pretty small. But we're on the lookout for reports and didn't see anything coming. We're like, oh, okay, it must have happened over the ocean or something, and then James reports, pretty cool, basically describing exactly what I would have expected a fireball of this size to be.
Based on the report, what was the description he gave you?
So yes, it was nighttime, 11 p.m. Northern Territory time, just after 11 p.m. And James was saying that from where he was, the sky was really clear, and that's quite important because sometimes you can see distant flashes from nearby or not so nearby lightning storm. He described it really, really well. So you saw the fireball quite low on the horizon, and then the two big flashes at the end. So at that point, that would indicate that the object fragmented significantly towards the end of its flight in our atmosphere.
The fact that it was a fireball rather than a meteor, what does that tell you about it?
Well, it tells us it packs quite a bit of energy. So the brightness relates to basically how much kinetic energy the object has, which is kind of mass times velocity squared. So basically, the faster it goes, the more light you get. Also, the more mass you have, the more light you get. So because it was either super fast or quite massive. But big fireball like this that you see on the low on the horizon, probably from a distance, means it would have been pretty energetic. So not your typical meteor that you might see every night. And
what about colour? Were you able to determine a colour?
So James described what he saw as green, which is pretty normal for meteor of this sort of speed, because the impact speed would have been, I can't remember exactly, it was somewhere between 13 and 15 kilometers per second, which sounds really fast, but as far as meteors go, that's not super fast. You can get meteors that go up to 72 kilometers per second. That's pretty fast. So in color, it doesn't really tell you too much about composition. Slower objects, if you get space debris, that's just deorbiting from low Earth orbits, have 7 to 8 kilometers per second. They tend to be a bit redder, a bit more orange. And then in that mid-speed range, a bit higher, beyond 12, 13 kilometers per second, they'll go a bit green. And as they get really, really fast, they'll go a bit bluer, but that's mostly a temperature thing due to speed. That doesn't really tell you much about the composition.
That's Dr. Hadrian Devipois from the Desert Fireball Network, and you can get in touch through their website or through Curtin University. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. The first Australian mainland cases of the deadly H5N1 strain of bird flu have been detected in migratory birds in Western Australia. The avian influenza variant was confirmed in both a brown skua and a southern petrel found on a remote beach at the Cape Legrand National Park near Esperance, 700 kilometres southeast of Perth. The discovery means the highly contagious virus, which has infected millions of birds globally, has now spread to every continent on the planet. The H5N1 variant had already impacted the remote Australian Southern Ocean territories of the McDonnell Islands and Heard Island, where it's killed tens of thousands of elephant seal cubs. The disease can also infect other mammals, including humans, with death rates higher than normal seasonal influenza. Australia's Bureau of Meteorology has officially declared El Niño active, and it warns that its modelling suggests this one could be the strongest such pattern of modern times. El Niño weather patterns are characterized by extended periods of warmer than average waters in the central eastern tropical Pacific Ocean and a drop in the Southern Oscillation Index. This disrupts climatic conditions across the globe, including extended drought periods in eastern Australia and an increase in the risk of bushfires. And the Weather Bureau is warning of reduced mid to late spring rains. El Niños typically cause warmer daytime temperatures across southern Australia through winter, spring and summer, with a longer, harsher fire season, and a delayed wet season in the top end with fewer tropical cyclones. It also means cooler nighttime temperatures in the winter with increased frost but a shorter snow season. Importantly, since most El Niños typically peak between November and January, an event emerging this early in the season will have a full 6 months to intensify. The Bureau says the rate of warming is already the fastest since 1943, and the modelling forecasts temperatures in the equatorial Pacific will continue to rise rapidly in coming months, possibly setting an all-time record later this year with a peak warming in excess of 3 degrees above average. And that would be well in excess of the previous post-1900 high of 2.65 degrees Celsius recorded way back in November 1902. A new study has shown that the risk of suicide among males can persist for years following a relationship breakup. The findings by the Australian Institute of Family Studies show that men who experience an intimate partner relationship breakup or separation have significantly higher rates of suicidal thoughts and attempts compared to those who would not, even years later. The new research is based on data from 10 to Men, the world's largest longitudinal study on male health, which examined the experiences of more than 20,000 men aged between 18 and 67. Well, it sounds like a dream come true, but researchers really are working on the creation of a nuclear diamond battery which could last thousands of years. The research by scientists at the University of Bristol and the UK Atomic Energy Authority is based on the use of radioactive carbon-14 from nuclear waste. As the carbon slowly decays, it generates a tiny but steady amount of electricity, while the diamond would safely contain the radiation. The result would be a battery capable of powering medical implants, sensors, even spacecraft for thousands of years. Scientists have identified a new species of shark in the tropical North Pacific waters off Australia. The discovery, named Dudgeon's walking shark, Hemicillium dudgeoni, has now been described in the Journal of the Ocean Science Foundation. The metre-long animal was discovered during a nighttime dive at Milne Bay off southeastern Papua New Guinea. Looking sort of like something between a wobbegong and a Port Jackson shark, these nocturnal epaulet sharks eat invertebrates off the seafloor and are not dangerous to humans. Fascinatingly, they're capable of using their 4 fins as limbs, allowing them to amble across reef flats at low tide. Similar species are found further south in Queensland's Great Barrier Reef. The findings have raised concerns about the new shark's vulnerability due to its restricted home range, habitat degradation, local fishing activity, and, of course, climate change. The challenge of trying to understand how to separate fact from fiction is nothing new. The ancient Greeks and Romans were laying down the basics 2,500 years ago. Mind you, they didn't always get it right. They often failed. But they did learn from their mistakes, and that paved the way for today's scientists. The skeptic's Tim Mendham says there are 5 lessons from ancient Greek and Roman science that ring surprisingly true in the face of misinformation in the modern world.
The ancient Greeks and the ancient Romans, they understood a lot about the world. They did philosophy really well, and they did attitudes towards how you look at the world, even if they didn't always get the right answers. In their philosophical discussions in the schools of academe, they would sort of discuss the various things you need to do to assess claims. They were no dumb bunnies. They understood all this stuff. Their advice on sharing knowledge and getting informed decisions and how to assess such things is basic. It's pretty straightforward. It's the sort of thing skeptics would promote now, 2,500 years later, and they are still correct, and they still face the same problems. The first one is that start with observations. You don't take anecdotes. You don't take someone's word for it. You look at what they've actually presented and the observation and collecting data before making a decision. Good heavens, you think you do that, but as we know from a lot of surveys, people don't. They just look at what someone tells them and think, oh, that must be true. The second thing is think critically. Critical thinking is the basis of skepticism. It's the basis of science. It should be the basis of everything you do in life, but it's not. The idea is that you look at potential sources of information, other authors and other people. That's where they came from. They didn't have TikTok and social media in the ancient Greek and ancient Roman world. world, but they certainly had people promoting stuff. And you've got to look at what they say and think about it. You don't just jump in and sort of follow them willy-nilly. Another thing is acknowledging what you don't know. This is a human trait. You don't know everything. Even you, Stuart, don't know everything.
I know, it scares me.
But you acknowledge it. You can't know everything, and there's nothing wrong with that.
It's not just that I don't know everything, although I want to. It's that I don't know what I don't know.
That's exactly right. But you acknowledge that. You don't think you've got an answer straight away. You don't think everyone has an answer. One person especially has an answer to every question. And you say things need a bit more thinking about. And there might be multiple explanations to things that really don't need them. So just go back to that second lesson, think critically, fill in the gaps that you have. Fourth one was sort of science as part of culture, by which they mean that science is influenced by the environment in which it's presented. This is the thing that worries everybody. You would think that science is independent of cultural thinking of the time. Not necessarily. You would like it to be, but it is influenced by what's around, what's important, what's not important, what's the current thinking. And the things that I was thinking about particularly was things that were sort of sacred knowledge about things like epilepsy and other illnesses. And what they did was they looked at it and they found out that, well, it wasn't so sacred. It wasn't something you can't look at. It wasn't something that came out of the sky from the gods or whatever. They can actually look at it, understand the way that people are thinking about it, and go beneath that. So you have to sort of always weigh what you hear and saying that it's part of culture rather than separate from it, that science is sort of individual beliefs and values will have a significant impact on the information they promote as factual or truthful. And that is actually what the scientific method is supposed to weed out, the individual attitude, the biases, by pointing out that, hang on, what you're saying here is not necessarily true. You're just hoping it to be true. And that's the way science works. So it is the opposite of pseudoscience, which works on, this is what I say is true. The last point that I make is that science is for everyone. You don't have to be a scientist to look at science. It's a teachable topic. It's certainly a teachable from critical thinking, and following critical thinking, there's the actual knowledge and the results of critical thinking. What they say is that the ability to acquire new knowledge is all about interest and willingness to learn rather than possessing any innate skill. You too can be a scientist, or at least you too can have a go at looking at how the world works. You don't have to leave it to somebody else. Be careful of leaving it to people who don't know what they're talking about, because that's a totally different thing.
That's the Skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.